Good morning, everyone. In this video, we'll continue with chapter 13, surface areas and volumes. So these are the formula that we have already studied in the previous video for cuboid, cube, right circular cylinder, right circular cone, sphere and hemisphere, the volume, lateral surface area or curved surface area and total surface areas are given here, which you have already studied in your ninth grade also. So let us move on to the next topic, volume of combination of solids. Let us quickly move on to exercise 13.2. So first question, a solid is in the shape of a cone standing on a hemisphere with both their radii being equal to 1 centimeter. So we are having a hemisphere and a cone on top. Both their radii is 1 centimeter. Height of the cone is equal to the radius. So height of the cone is also 1 centimeter. We have to find the volume of the solid in terms of pi. That means we don't have to substitute the value of pi, we just have to leave it as pi. So let us take conical part height to be h, which is same as radius r, 1 centimeter. Radius of hemispherical part and radius of the conical part are the same, r, 1 centimeter. Now volume of the total solid will be volume of the cone plus volume of the hemisphere. Volume of the cone is 1 by 3 pi r square h and volume of the hemisphere is 2 by 3 pi r cube. We are not going to substitute for pi. We'll just take radius r to be 1. So when we substitute, we get the answer to be pi centimeter square cube. So this is the volume. Now the next one, Rachel, an engineering student, was asked to make a model shaped like a cylinder with two cones attached at its two ends by using a thin aluminum sheet. The diameter of the model is 3 centimeter and its length is 12 centimeter. If each cone has a height of 2 centimeter, find the volume of air contained in the model that Rachel made. Assume that outer and inner dimensions of the model to be nearly the same. So this is the figure we are having. We are having a cylinder and cones attached at both the ends. Given that diameter of the model is 3. So the radius will be 1.5 centimeter. And length of the model is given to be 12 centimeter. That means total height is 12 centimeter. Okay. Now first, let us take height of the conical part. Each cone has height 2 centimeter is given. So the top part is 2 and the bottom also is 2. So height of the conical part is 2 centimeter H1. Now height of the cylindrical part H2 will be total model is 12 minus 2 on top minus 2 on the bottom also. So it will be 8 centimeter. 12 minus 2 minus 2. Now radius of the cylindrical part and the conical part will be the same, which is 3 by 2 or 1.5 centimeter. Now volume of air present is what we are asked to find, and it's given that outer and inner dimensions are almost the same. So we don't have to consider the thickness, just the values that are given here. So volume of air will be volume of cylinder plus 2 times volume of cone because there's one top and bottom. So pi r square H2 for the cylinder plus 2 times 1 by 3 pi r square H1 for the cones. So we'll substitute the value for radius, height H1 and H2. We'll get pi into 9 by 4, 8 plus 2 by 3 pi, 9 by 4 into 2. So when we solve all this, we'll get 21 pi because it's 21 which is a multiple of 7. So we'll take pi value to be 22 by 7. Cancelling 7 and 21 as 3, we'll get 66 centimeter cube to be the volume. Now the next one, a gulab jamun contains sugar syrup up to about 30% of its volume. Find approximately how much syrup would be found in 45 gulab jamuns, each shaped like a cylinder with two hemispherical ends with length 5 centimeter and diameter 2.8 centimeter. So, how does the gulab jamun look like? It looks like this: two hemispherical ends and shaped like a cylinder. Okay, previous one we had conical ends. Here we are having hemispherical ends. Okay, now here what all informations are given to us. Length of the gulab jamun, complete jamun, is 5 centimeter. So the total length is 5 centimeter. Now diameter is given to be 2.8. So the radius is 1.4. Now we had already seen in the previous video that for a hemisphere, radius and height are the same. So height of the hemispherical part is 1.4 and on the other side also 1.4. Total height is 5, height or length. Total length is 5 and 1.4, 1.4 we have to subtract. So height or length of the cylindrical part will be 2.2 centimeter. Okay, so let us describe that first. Radius of the cylindrical part and radius of the hemispherical part, small r, is same, which is equal to 2.8 by 2, 1.4 centimeter. Length of each hemispherical part will be radius, height or length and radius are the same, 1.4 centimeter. So the length of the cylindrical part total is 5 minus 2 times 1.4, which is 2.2 centimeter. Now we have to find volume of one gulab jamun first. So for that, volume of the cylindrical part plus 2 times volume of the hemispherical part. So we'll substitute the formula: pi r square h plus 2 times 2 by 3 pi r cube. We'll get, after substituting the values of height and radius, as 25.05 centimeter cube. So this is the volume of one gulab jamun. But in the question it's given that there are 45. So we have to multiply by 45. Now volume of 45 gulab jamuns will be 45 times 25.05, which will be 1127.25 centimeter cube. Now what do we actually have to find? Find how much syrup would be there. Now what is the information on syrup? 30% of the volume will be syrup. So volume of the sugar syrup will be 30% of the 45 gulab jamun volume. So 30 by 100 of 1127.25, which we had found here. We'll get 338.17 or approximately 338 centimeter cube. So this much sugar syrup is found in 45 gulab jamuns. Okay, so first we find the volume of one gulab jamun, then we multiply by 45, so we get the total volume. Now for sugar syrup we need 30% of it, so 30% of the volume we calculate, then we get the final answer. Okay, now moving on to the fifth question. A vessel is in the form of a inverted cone. So this is the figure for you, inverted cone. Its height is 8 centimeter and radius is of its top, which is open, the top is open, is 5 centimeter. It is filled with water up to the brim. So completely it is filled with water. When lead shots means like small bullet kind of thing, small round spherical bullets kind. Okay. So when lead shots, each of which is a sphere of radius 0.5 centimeter, are dropped into the vessel, 1/4 of the water flows out. You know that the vessel is filled with water. Now, if you're going to drop lead shots, then there's going to be overflow of water, isn't it? So for each lead shot, 1/4 of the water, means lead shots are put inside and 1/4 of the water flows out. How many? Find the number of lead shots dropped in the vessel. Okay, so number of lead is what we have to find. Now let us first describe height h will be 8 centimeter. Radius of the conical vessel is 5 centimeter. Radius of the lead shots, which is a sphere, is 0.5 centimeter. Now, suppose n number of lead shots are dropped inside. Now, volume of the water spill, that is water displaced, will be same as volume of the dropped lead shots. How many are dropped? N times sphere. So, volume of the cone, how much water is filled? 1/4. So 1/4 of volume of the cone is same as n times 4 by 3 pi r cube. What is 4 by 3 pi r cube? Volume of the sphere, which is the lead shot. So 1 by 4 into volume of the cone is 1 by 3 pi r1 square h is equal to n times 4 by 3 pi r2 cube. Okay, volume of the water spilled is 1/4 of the volume of the cone. So we have substituted the formula. Now let us substitute for radius and height. We get 100 to be the value of n after calculation. So hence the number of lead shots dropped in the vessel is 100. So in this vessel, if we drop 100 lead shots of radius 0.5 centimeter, then 1/4 of the water will be spilled out. Okay. Now moving on to the sixth one, a solid iron pole consists of a cylinder of height 220 centimeter. So this is the first cylinder and base diameter is given to be 24 centimeter, which is surmounted by another cylinder. That means one more cylinder is there on top of this of height 60 centimeter and radius 8 centimeter. Now find the mass of the pole given that 1 centimeter cube of iron has approximately 8 gram mass. And they've also asked us to use pi to be 3.14. So now height h1 of the largest cylinder, the bottom one is 220 centimeter and radius, note that diameter is given to be 24. So radius is 24 by 2, 12 centimeter. Height h2 will be 60. Radius r2 is 8. Radius only is given for the smaller cylinder directly. Now volume of the pole will be volume of the larger cylinder plus volume of the smaller cylinder. So same formula, pi r1 square h1 plus pi r2 square h2. So we'll substitute the values for r1 r2 h1 h2. We'll get 111,532.8 centimeter cube. Now they have not asked us the volume, they've asked us the mass and they've also given the conversion that 1 centimeter cube is having 8 gram mass. So 1 centimeter cube 8 gram. Now this much of volume will be 111,532.8 into 8 grams. So we will get 892.262 kilogram. So if you leave it as gram, it's a very big number. That is why it is better to convert into kilograms. Okay. Now moving on to the seventh one, a solid consisting of a right circular cone of height 120 centimeter and radius 60 centimeter standing on a hemisphere of radius 60 centimeter is placed upright in a right circular cylinder full of water such that it touches the bottom. Find the volume of water left in the cylinder if the radius of the cylinder is 60 centimeter and its height is 180 centimeter. So what is given to us? We are having a solid. How is the solid looking like? There's a hemisphere, base and a cone on the top. Okay. Now cone height is 120, radius is 60 and for hemisphere radius is 60. We know that hemisphere radius and height are the same. So height is also 60. Now this solid is put inside a cylinder full of water. Again, same water displacement type. So full of water. Now what is the height of the cylinder? 180, radius 60. 120 plus 60, 180. So cylinder and the whole solid is of the same height and same radius also. Now what do we have to find out? Find the volume of water left in the cylinder. So after displacement, what is left is what is asked. Okay, so for that, first we will write radius of the hemisphere and radius of the conical part is 60. Height of the cone is 120. Height of the cylinder is 180. And radius of the cylinder is again 60. So how much volume will be left? Volume which was already there, that is volume of the cylinder minus how much is displaced. How much will be displaced? Volume of the solid will be displaced. So volume of water left is volume of cylinder minus volume of solid. Now volume of solid is volume of cone plus volume of the hemisphere, this 2. So that we substitute, substituting the formula for all of them. For cylinder, pi r square h1, cone 1 by 3 pi r square h2, hemisphere 2 by 3 pi r cube. So after solving, we'll get 3,60,000 pi centimeter cube. We'll substitute the value of pi as 3.14 because 22 by 7 will not get cancelled over here. Then we get 1.131 meter cube. Here again, the value is very big in terms of centimeter cube. So we are converting it into meter cube. This much volume of water is left in the cylinder after the solid is placed in it. Okay. Now, moving on to the eighth question. A spherical glass vessel has a cylindrical neck. So this is it looks like a bulb, isn't it? So spherical vessel and it has a cylindrical neck of 8 centimeter long and 2 centimeter diameter. In all the questions, note whether they have given diameter or radius. Now, the diameter again of the spherical part is 8.5 centimeter. By measuring the amount of water it holds, a child finds its volume to be 345 centimeter cube. Check whether she is correct, taking the above as the inside measurements and pi as 3.14. So they've given the volume also. You just have to check if it is right or wrong. So first, height is 8 centimeter for the cylinder and radius R2 is 1. 2 is the diameter. Now again, radius of the spherical part is 8.5 by 2, so 4.25 centimeter. Now volume of the vessel will be volume of the sphere plus volume of the cylinder, which is 4 by 3 pi r cube plus pi r2 square h. Substituting the values, and they've given pi value to be 3.14, so we'll substitute that also. We'll get 346.51 centimeter cube. But what did the child find? 345. They are not the same, so the child is wrong in calculating the value. Okay. So with this, we have come to the end of this topic. We'll continue in the next video. Thank you.